Okay, this one, all these questions are at that sort of grade 8 and probably mostly grade 9 barrier, and mostly because they usually involve a degree of algebra connected in with the rest of it and multiple stages. So, I mean, key to this question is just to break it down into the two separate prisms. I've got this prism here, the cuboid prism, and I've got the hemispherical prism, or sorry, semicircular prism there. So bottom here is x times x, which is x squared, times it by the height there. X squared times 2x is 2x cubed. And then I've got this section here. I know I got pi r squared for a whole circle, but let me see if I may have worked this out for a whole circle. We'll see. So, but I've got half of that distance there, which is a half x. So pi a half x squared, and yeah, that's what I've done. I've worked this out for a whole circle, so that's incorrect there. That's correct. And then this is worked out for a whole circle, right? Because I got pi r squared times by x. What I needed to do was then, which is a typical mistake, silly mistake to make, which is in the end I've got to divide that by 2 for a semicircle. So instead of that, I've got 2x cubed plus 1/8 pi x cubed. Do we agree there? Right, I've got a hemispherical bowl. So the volume of a whole hemisphere is 2/3, right? Because the volume of a sphere is 4/3 pi r cubed. So the volume of a whole hemisphere is 2/3. It's half of the 4/3 pi r cubed. So 2/3 pi r cubed. So 2/3 pi 6 cubed. 6 cubed is 216. So 2/3 pi 216 is 144 pi. Now, water only fills 2/5 of this bowl. I think one mistake might be, I think that there are different ways of going about this question, but if I take now 2/5 of the whole volume of that bowl, I come out at 57.6 pi centimeters. I'll add that in, centimeters cubed for a volume. So that is then poured into here. So, and I'm going to need to work out I'm going to need to work out this radius here, the radius of the surface of the water. So that's what I'm trying to work out. So I know that this radius here is going to be 1/3, right? The whole of this volume of water here is 1/3 pi r squared h. So 1/3 pi r squared times by 12, which is h, is equal to what I found here, 57.6 pi. So 1/3 of 12 is 4, so I can just state this as 4 pi r. Oh, I've also divided by pi here. So to go from here to here, I've divided both by pi. And I've also just simplified this 1/3 12 into 4. Then divide by 4 gives me r squared is 14.4, and then taking the square root, r equals 3.79 to 3 significant figures. A sphere has radius 3x, a cone has a base radius 3x, and a slant L. The curved surface area of the cone is equal to the surface area of the sphere. Express, I think this should read, express L in terms of x. Give the answer in its simplest form. So you'll be given your sphere area, which is 4 pi r squared, and you'll be given your curved surface area, which is pi r L. That's just the curved amount here. So I've got 4 pi 3x squared, which gives me is equal to pi 3x L, and then I've got I'm dividing both sides by pi. So divided both sides here by pi. That gives me 4 times by 9. Don't forget to square the coefficient as well. 4 times by 9x squared is equal to 3xl. And then, so I've got 36x squared equals 3xl. Divide both by 3x gives me 12x equals L. And that's that. On this diagram, all lengths are given in centimeters. A cylinder and cone are joined together to make a solid. The cylinder has radius r and height r plus 5. The cone has radius r and slant height 9r over 2. Show that the total surface area of the solid in centimeters squared is 5 pi r over 2 times 3r plus 4. Okay, so the curved surface is pi rl. So I've got pi r times by 9r over 2. I can rewrite this like this, yeah? If these are times by a fraction here, I can write them all with this on top. So I've got 9r squared pi over 2. That's my curved surface part here. Then I've got the part which goes around the cylinder. Now the bit around the cylinder is the length of that is, if I unfolded it, it would be a rectangle. And the length of that rectangle would be the same as the circumference of that circle. So it's 2r, it's pi d, isn't it? Or 2 pi r. So it's 2r times by pi along here, and I've got r plus 5 along there. So I'm going to multiply those together, and that gives me 2r squared pi plus 10r pi, right? Just expanding out that bracket. All of that times by this, and all of that times by that. Okay? So I've got 2r squared pi and 10r pi. And then I've got, don't forget the bottom part here, because if it's the surface of the solid, it includes this bottom part, the circle on the bottom, and that's just pi r squared. So let's put all those things together. I've got 9r squared pi over 2 plus 2r squared pi plus 10r pi plus pi r squared. Now, if we have a look, this here, I mean, you can do it however you like, but I decided to rewrite this out as 4.5 r squared pi, because that's what this will come to. And then I've got another 2r squared pi and another one more r squared pi. These are all like terms here, aren't they? Right, that, they're all to do with pi r squared. They're just different amounts of pi r squared. So that all together, that's going to come to 7.5 r squared pi. And then I've still got this 10r pi here, so plus 10r pi. So I've got 7.5 r squared pi plus 10 r pi, or pi r. And then I've got to get it to match this format here. Now this format here, if you think about it, is 2.5 pi r. And that is a common factor here. 2.5 pi r is a common factor. So I rewrote this out as 2.5 pi r, and then, yeah, you have to times it by 3r to get to 7.5 r squared pi, and you had to times it by 4 to get from 2.5 pi r to 10 pi r. And this is exactly the same as that, so I've then just rewritten it in the format which they've got. So I think this question is all about making a start and then just and accumulating marks as you go for each part, and then trying to put it together and trying to make it match. A sphere has radius x centimeters. A hemisphere has radius y centimeters. The shapes have equal volumes. Work out the value of y over x. Give your answer in the form what a to the power of 1/3, where a is an integer. So I set this situation up. A sphere radius x centimeters, that would be this, 4/3 pi x cubed, is equal to a they have equal volumes, so equal to a hemisphere radius y. So hemisphere is 2/3, right, because it's half of the 4/3, 2/3 pi y cubed. So if I then divide both sides by 2/3, which would be the same as times it by 1.5, I've got 2x cubed, and also divide both sides by pi. I've got 2x cubed equals y cubed. Take the cube root of that. That gives me the cube root of 2 times by x equals y. And so I now need to divide both sides by x. So I've got y divided by x. So on this side I've got y divided by x. And on this side I've got the cube root of 2. The cube root of 2 is 2 to the power of 1/3. I've solved the question. Question 6, a fairly straightforward one. If you get one like this, then you know you're in business. It's pretty straightforward. So I've got a sector area and I want to work out the shaded segment, so I got the sector area, and if I subtract the triangle area, I'll get the segment. So my sector area is 40 out of 360, that much of a circle, pi r squared, which gives me 1/9 pi r squared, which I think comes in at 113.09, and you keep all the accuracy at that point. The area of the triangle, I need to realize I've got a non-right angle. I need to find the area. It's going to be a case of half AB sine C. So half 18 is 18 for one side, 18 for the other side. So half 18 times sine 40 is 104.13, and so on. Subtract them, and I get my result, which comes in at 8.97 to 3 significant figures. Shape is made from a semicircle and a triangle. Calculate the perimeter of the shape. I know these two sides. What I don't know is this side, that perimeter. To find that out, I'm going to need to do pi times by the diameter, but I don't know the diameter. So to find the diameter, I'm going to use the cosine rule because I have two sides and an included angle. So we need cosine rule, two sides and included angle. So I'm going to just write out my cosine rule. A squared equals b squared plus c squared minus 2bc cos a. So a squared equals, I've just labeled up the sides. There's my a squared, so there's my angle a. B and c can be either way around. So a squared equals 6 squared plus 11 squared minus 2 times 6 times 11 cos 85. So a squared is 145.49. Take the square root. A is 12.06 and keep all the accuracy. That is my diameter. So my perimeter is pi times that plus 6 plus 11 gives me 54.89 for the perimeter of the whole shape. Thank you for that. No, this is wrong, isn't it? I've made exactly the same mistakes I made earlier in getting so involved with the working out, and this happens all the time with people's exam questions. They get so pleased with themselves they're doing the working out, they forget to go back to the question. This gives me the perimeter of a whole circle, right? This pi times 12.06. But what I needed to do really was take that and split it, divide it in two, because I'm dealing with a semicircle. So instead, let's work that out instead. So my calculator. What does that come out as? Can someone help me out? Okay. Do I have you added 6 and 11 to that? Okay. Times by pi. Okay. And then someone help me out who's done the working out for this. Plus the 6 plus 11, yeah? 23 point... It's ruining the video, guys. So when we did halve this, plus added the 6 and 11, we got to 35.95 to 2 decimal places. Next question. Diagram shows an arc AB of a circle center O. Triangle OAB is equilateral. Work out the length of arc AB. This one's dead straightforward. If it's equilateral, all angles are 60 degrees. That's 60 degrees. So I've got that much. I've got 60 out of 360, or 1/6 of pi times by the diameter. Now the diameter is 2 lots of the radius, so the diameter is 18. That comes to 8/3 pi, which is 8.38 to 3 significant figures. And last question, question 8. I've got 2 squares. I need to find the area of this shape. Area is comprised of 2 squares. So my 2 squares worth of area, each square is 8 times 8. So each square is 64, so I've got 128 centimeters squared for my square areas. Then I've got my sector areas, and I think some people may just may not maybe sort of stymied Slimy means a good word, means kind of stopped from completing this because they don't know how much of that one and how much of this one there is. But if you can put them together, and if they'll add together to make a semicircle. This time I think I've managed it. We've got a semicircle here. So for the whole circle I've got pi r squared. The radius here will be 8 because the radius is one of the sides of the squares. So pi r squared, so that gives me pi 8 squared, which is 64 pi. And this time I've remembered to divide it by 2 to get half of the circle, which is 32 pi. If I add 32 pi to 128, it comes in at 228 centimeters squared.